Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss about the heat exchanger. So in this lecture we will discuss about the heat exchangers. So what are the heat exchangers? These are the devices which are used to heat one fluid. This fluid can be water, it can be liquid or gas. The fluids can be liquid or gas. So these are devices which are used to heat one fluid and cool another fluid. So in heat exchanger, usually we are going to heat one fluid and cool another fluid. So this is a simple definition of the heat exchanger. So in the heat exchanger, the two fluids are not mixed with each other. Suppose this is a hot fluid in a beaker and the cold fluid is coming toward the beaker, and this is the stirrer. So when we stir the hot and cold fluid, the heat will transfer from the hot fluid to the cold fluid. The temperature of the hot fluid will decreases and the temperature of cold fluid will increases with the passage of time in this beaker. So this is an open system in which two fluids are mixing, or this is a simple mixer. But in heat exchanger, the two fluids, the hot and cold fluid, are separated from each other by a wall, or by this wall. So the hot and cold fluid are separated from each other by a wall. So this wall. So now suppose this is the hot fluid. This is the hot fluid. And this is the cold fluid. This one is the cold fluid. As the hot fluid is passing, this is the tube of the heat exchanger. This is the tube of the heat exchanger, and this one is the shell of the heat exchanger. This is the shell. This is the shell of the heat exchanger. Now the hot fluid is passing through the tube of the heat exchanger, and the cold fluid is passing through the shell of heat exchanger. As these two fluids are passing through the heat exchanger with the passage of time and with the x direction, with the length of heat exchanger, the hot fluid will give its heat to the cold fluid. So this hot fluid will give its heat to the cold fluid with the passage of time and with the passage of length of the heat exchanger. The hot fluid will give its heat to the cold fluid. The heat will transfer from the hot fluid toward the wall of the tube. This is the wall of the tube. This is the wall. This is the wall of the tube. After passing through the wall, the heat will transfer to the cold fluid. Heat will transfer towards the cold fluid. The cold fluid will become heated. So at this point, this is the heated fluid, the heated cold fluid. So at this position, the cold fluid will become heated off. Similarly, at this position, the cold fluid will become heated off, and at this position, the hot fluid will become cold, because this hot fluid gives its heat to the cold fluid. So the cold fluid become heated, and the hot fluid become cold with the passage of time and with the length or volume of the heat exchanger. Now there are various types of the heat exchanger. One is the double pipe heat exchanger, one is the shell and tube heat exchanger, other are the compact heat exchanger. So the simple type of heat exchanger is the double pipe heat exchanger. In the double pipe heat exchanger, we are using two pipes. This is one pipe which is called the tube. And this is another pipe, large diameter pipe, which is called the shell. So this is called simple double pipe heat exchanger. Now the flow in the two pipe can be counter flow or it can be co-current flow. Co-current flow, co-current flow, or it can be counter current flow. Counter current heat exchanger or co-current heat exchanger. HX is for the heat exchanger. What is HX? So co-current heat exchanger and counter current heat exchanger. Now what is mean by the co-current heat exchanger? So what is mean by the co-current heat exchanger? In the co-current heat exchanger, the hot fluid and the cold fluid are flowing in the same direction through the heat exchanger. So in the co-current heat exchanger, this was the cold fluid and this was the hot fluid. So in the co-current heat exchanger, the cold fluid and the hot fluid, the cold fluid, these two are the cold fluid and this one is the hot fluid. So the cold fluid and the hot fluid are flowing in the same direction, while in the counter current heat exchanger, or the counter current double pipe heat exchanger, the hot fluid is flowing through one side of the heat exchanger, while the cold fluids are entering from other side of the heat exchanger. So this is called the counter current heat exchanger. In the counter current heat exchanger, the hot fluid is flowing from one side. The hot fluid is passing from one side of the heat exchanger, while the cold fluid are passing from the opposite side of the heat exchanger. As the hot fluid are flowing in the this was the tube. As the hot fluid is flowing through the tube, the hot fluid will give its heat to the cold fluid. So the temperature of the hot fluid will decreases with the passage of time and with the passage of the volume or the length of heat exchanger, and the temperature of the cold fluid will increases also. The temperature of the cold fluid increases. The temperature of the cold fluids will increases with the passage of time and with the length of the heat exchanger, and this arrangement is called the counter current double pipe heat exchanger. So this was co-current and counter current heat exchanger. Now we can draw a graph for the two heat exchanger. So we can simply we can show the counter current and co-current heat exchanger by a graph. This was all for the co-current and counter current heat exchanger. This was the co-current heat exchanger. The hot fluid and the cold fluid. This is the cold fluid, cold fluid. This is the cold fluid, and this one is the hot fluid, HF, hot fluid. So the cold fluid and hot fluid are moving in the same direction in the co-current heat exchanger, while in the counter current heat exchanger, the two fluids are moving in the opposite direction. So while in the case of counter current heat exchanger, the two fluids are flowing in the opposite direction. So suppose the hot fluid is flowing in this direction, while the cold fluid is flowing in this direction. So the hot fluid is flowing in this direction and the cold fluid are flowing from this direction towards this side. So this is called the counter current double pipe heat exchanger. Now what will be the graph for this is the counter current heat exchanger, and this is suppose this is the co-current heat exchanger. This is the tube, the yellow one is tube, and the large pipe is the shell. So this is the hot fluid and these are the cold fluid. cold fluid. So what will be the graph for the co-current heat exchanger? This is the co-current heat exchanger, and this is the counter current heat exchanger. So suppose this is the, and this axis we will plot the temperature, and this is the volume or length of the heat exchanger. So the hot fluid in the co-current heat exchanger is the hot fluid flowing through the tube. It will give its heat to the cold fluid, and its temperature will decreases with the passage of time. So the temperature of the hot fluid will decreases with the passage of time and with the length of the heat exchanger. So the temperature of the hot fluid will decreases all. Now this is the graph which show the temperature and the length of the heat exchanger. So this is shows the length of the heat exchanger or the volume of the heat exchanger. This shows the temperature. Now for the counter current heat exchanger, the temperature of the hot fluid in decreased. So this is the temperature of the hot fluid was decreased, and the temperature of the cold fluid was increased. So this is the temperature of the cold fluid was increased. The heat exchanger. So the temperature of the cold fluid. So the temperature of the hot fluid, the temperature of the hot fluid decreased. The temperature of the hot fluid. This is the hot fluid. So the temperature of the hot fluid was decreased. Yes. And the temperature of the cold fluid was increased. Temperature of the cold fluid was increased. In the heat exchanger, similar temperature of this cold fluid was also increased. So this is for the co-current heat exchanger. For the counter current heat exchanger, so the length of the heat exchanger, this is the temperature. So for the counter current, the temperature of the hot fluid was decreased. Temperature of the hot fluid was decreased, something like that. And the temperature of the cold fluid was increased. And the temperature of the cold fluid was temperature of the cold fluid was increased. This is for the temperature of the hot fluid was decreased. This is the temperature of the hot fluid. The hot fluid was decreased, and the temperature of the cold fluid was decreased. This one. This is the temperature. So the temperature of the hot fluid was decreased. Temperature of the hot fluid was decreased. So the temperature of the hot fluid was decreased. Is shown by this line, and the temperature of the cold fluid was increased. Is shown by this yellow. So the temperature of the cold fluid. So this is the temperature versus volume or length graphs for the co-current and counter current heat exchanger. Thank you very much.